this is just part of the calculus. We're going to have to come back to this in total once we've done trigonometry calculus, which is why I was holding off. But this is going to be tested in the test coming up. Okay? Remind me to tell you about something like that in a minute. Alright, so calculus and kinematics. So calculus will be used in practical situations with displacement, velocity and acceleration. You would have learned about this probably briefly for your IGCSE. Does it ring any bells? No. All the expressions that you will be looking at have a variable of t because they're all to do with time. So displacement talks about the movement of a particle. The velocity is how fast it's going, and the acceleration is how fast the speed is increasing. Yes? Now, they are all connected to each other by, if we have an expression for displacement, now displacement is given the letter S, I don't know why, okay? Just it is. So if an expression is given for displacement, we can differentiate that expression and it will tell us about the velocity of an object. So in other words, V would be equal to ds dt, okay? Because remember we said to differentiate it would be ds and it's over dt because the expression in terms of time. In a similar way, the velocity expression could be differentiated to give us an expression for acceleration. So the acceleration would be dv dt or d squared s dt squared. Remember this indicates it's the second derivative. In other words, we differentiated this expression twice to get to that, right? So that's the differentiation. Obviously, if we can differentiate from here to get to here to get to here, then we must be able to integrate to get from here to here to here. All right? So, a kind of question that you might have, they may well focus on velocity. So they might give you an expression for velocity. They may ask you something about the acceleration, which involves you differentiating it. And they might ask you a question about displacement, which would involve you integrating it. Okay? But that's just one suggestion. They could ask you anything about this, but that's how they're all connected. Do we understand? Yeah? Now, what it says here is don't forget that integrals have constants of integration attached to them. So, if you were given an expression for acceleration and you needed to find a rule or formula for the velocity, they need to give you some additional information. So they will give you some extra information to be able to work out if there's a constant of integration or not. What's that? This part here is becoming more and more popular and more common in questions. So if you are looking at the velocity function, okay, so if we're looking at the velocity function, then the definite integral between two times tells you about the distance travelled. Okay? So if we have an expression for velocity and we integrate that between two values for t, that tells us about the distance of it travelled. So if they're talking about distance travelled, it means you're going to be integrating between two values. Yes? Alright, so
are those two values like from point A to point B?
Yeah, so from time, like from 5 seconds to 1 second, or from 3 seconds to 0 seconds, whatever the time period they last about. Okay, we're all good with that? Alright, so let's do some examples. Alright, so a particle moves in a straight line with velocity v equals blah blah, for t is greater than or equal to 0. Okay, so our time starts at 0. Should be a given because you can't go into negative time. Where v is in centimetres per second and t is in seconds. Lovely. Find the acceleration of the particle after 2.7 seconds. So, what does anyone suggest we might do? Yeah? Not yet. Why not yet? What does this tell us? And what this asks us about? You did, Jennifer. So, in order to go from velocity to acceleration, we differentiate it. So we're going to differentiate this expression first, and then, Olivia, we will stick the value in. Yes? So, dv dt, or maybe we'll write a equals dv dt. So when we look back at this, we know what we're doing. So what's the derivative of 12t minus 2t cubed minus 1 now? Ali, what has that? So we're differentiating. Minus 6. Anything else? No? Okay, good. Alright, so that's our expression for our acceleration. Yes, so power comes in front, table of power. And when there's just a letter there, remember the letter drops off and we just leave the value. If there's a constant, that goes. And then what we have to do is stick that value of 2.7 into there, yes? So at 2.7 seconds, acceleration is 12, take away 6, 2.7 squared, which is, I don't know. Alright, so next question says find the displacement of the particle after 1.3 seconds. So what are we going to do now? We're talking about displacement. Well, remember, if we start with our original, we only have to integrate it once. So, displacement is going to be the integral of the velocity with respect to time. So we're going to say it's the integral of, I've forgotten what the expression is, 12t minus 2t cubed minus 1. Okay? That sounds healthy, doesn't it? Alright, so let's integrate, baby.
12 squared over 2.
12 minus. Let's go with baby set. So 12t
minus 2
or secretly t. Let's do t there. Okay? Oh! Well, hang on, what are you moving it? But don't get this information.
Yeah.
Let's keep going. So this is 6t squared minus t to the 4 over 2.
It's minus c plus c.
So it's minus t and then plus constant of integration. Okay? Well, I'm thinking that a displacement of a particle when time is 0 is going to be 0. Are you hearing that? So when if you haven't started moving, if your particle hasn't started moving, then your displacement is going to be 0. Yeah, it's going to be when the time is 0. Yeah, so if you're starting off, time is 0, then the displacement is going to be 0. So if we substitute that in, we would say 0 equals 6 lots of 0 squared minus 0 to the 4 over 2 minus 0 plus c, which means that c is 0.
So then we would put. So then we go back.
So then now we can. So we've established that c, is 0. So this here is our expression for displacement. So 6t squared minus t to the 4 over 2 minus t. We don't have to write plus c. Yeah, do you want to do that? I mean, that's what I would suggest for this situation. So now, because they've asked us specifically after 1.3 seconds, we now substitute that value into the calc. obviously these questions that we're doing would have been on paper 2 where your calculator is available to you. Right, so there's that answer. Alright, so a particle moves in a straight line, its velocity blah, blah, is given by blah, blah. Find the velocity of the particle when t is 1. So you have 1 mark, what can you do? So extra time is worth 2 marks. Substitute it into Trisha?
Yeah.
What will we do?
So what we will do is that first you have to differentiate.
Do you?
Yeah.
Interesting.
Or integrate.
Do you? Okay, what does this expression give us?
Velocity.
What do they ask us?
Never mind, you don't do either.
So what do we do?
All we do is that you put the one into the equation.
Nothing, got it in.
What's choosing? Look at the question, I just looked at that one. Look at the question.
Well, that's interesting, because perhaps that's what you do in person. It's okay, that's what they
The
do.
shade was the rose.
If it's more than 5 centimeters, 5 words Alright, so, again, it's on the calc paper, so you don't have to stress too much about your mental math, but, what's our answer? So what? And we would need to make sure we've got units, so meters per second. So ms minus 1. Remember, that's how that's right there. Physics. Right, next one says find the value of t for which the particle is at rest. Well, what does that mean?
Zero.
What's 0? The velocity times. Ain't nothing.
Yeah, it's still the funny value of t.
We need to find the value of t for which the particle is at rest. So if something is not moving,
It's not accelerating.
it's not accelerating, but also it's not stopping. It's got no speed, has it? That's what it says. That's what we started with.
The velocity is at 0.
Alright, so if we can go back to the video, you can find out. Alright, no, so find the value of t for which the particle is at rest. If something is at rest, the velocity is going to be 0. Okay, so if something is at rest, the speed of it, the velocity is going to be 0. So what you're going to do is say that 0 is equal to t squared minus 4 cubed. And you're going to solve that.
When you put 1 squared,
No, sweetheart, because you're trying to find the value of t. Okay? So, 0 equals this expression cubed. So, we're solving this. We're undoing our operations. So, the first thing we need to deal with is this power. So, we're going to do the opposite to cubing. What's that?
cube root.
Cube root. So, we're going to cube root both sides. What's the cube root of 0?
0.
So, we're going to say 0 equals t squared minus 4. You with me? Yeah? So you can either complete the square on it, not complete the square, you can either factorize this, knowing that it's the difference of 2 squares, or you can say that t squared is equal to 4. So it's either 0 equals that, so either of these two. So then to find t, you would square root 4, yes? So it's going to be plus or minus 2.
But then wouldn't that t squared just be negative t squared?
So this would be t is equal to 2 or negative 2. It's the same answer. Yes? But, because when you square root anything at this level, you must remember that you've got both the positive and negative options. Because negative 2 multiplied by negative 2 gives you 4. As does 2 multiplied by 2. Alright, so you've got to be careful when you're square rooting stuff to try and make sure you've got both options. However, we go back to the original question, and what did it say about, oh, it didn't. Oh, well anyway, we're talking about between 0 and 3. Is time going to ever be negative? No. So what, then we would have to say then that time is 2 seconds. Yeah? Make sense? So whilst we officially have two answers, secretly, for a practical situation, we're only going to have one. Okay, so we know it's at rest at 2 seconds. Now, it's asked us to find the total distance of the particle in the first 3 seconds. Now, you've got to be careful here, because remember, to find the definite integral, what do we have to keep an eye on when we're finding definite integrals? No, so if I was to try and find the definite integral of this function here between this point here and this point here, no.
Oh, this is when you.
So if I knew that this was 5 and this was 0, I wouldn't be able to find the definite integral between 5 and 0. Why not?
It has to be on the left is in the negative and the positive side. No.
What's special about this area compared to this area? Negative and one's underneath it, isn't it?
Yeah.
And one's above it. Yes?
Mm-hmm.
And so that means that if I were to just find the definite integral between 5 and 0, I wouldn't get the right answer, would I?
No.
So I'd have to need to know this point here, so let's pretend that that's 2. I would have to find the integral of 5 and 2, and then 2 and 0, and make sure that I'm going to negate this one, because that's negate just means make it the opposite sign, because it's underneath it. Alright? Remember that? And so this situation applies here, and it's something perhaps, and this is why I chose this one, because it's probably something that you're not necessarily immediately going to think about. And you are more likely to just say, oh great, I'm going to find the integral between 3 and 0. But you can't do that. What are we going to do though? Because we don't necessarily know too much about it. They did ask us to find the velocity of the particle when t is 1. What value did we find that was? Negative 27, yes? So we knew that when t is 1, it's in the negative area, which means that our graph is going to be below the x-axis. They then asked us to find when the particle is at rest. So that means it's when it's 0. We know that it happens at 2. That should indicate to you that we're going to have to make sure that we split our integral up in between 2 and 0 and 3 and 2. Does that make sense to you all?
Yeah.
So, from these questions, like we don't necessarily really know what this looks like. It's a cute, well, that's not a cute little chart. We don't really know what this graph looks like, although we could plot it on our calcs because it's in the calc exam. Alright, but we don't really know what it looks like. But we did know that when t was 1, that we had a negative velocity, which means that whatever our graph looks like, at the value of 1, our graph's down here somewhere. At the value of 2, our graph was 0. At the value of 3, we don't really know what's happening, but if it's gone negative here to 0, it's probably going to be in the positive area. Yes, that makes sense? So they've asked, so it's probably doing this. They've asked to find the total distance particle travelled in the first 3 seconds. So we can't just do the integral between 3 and 0, because some of our graph was above, some of our graph was below. So we're going to have to cut it up into this section here, and then this section here, we're going to have to change the sign. You with me now? Mm-hmm. Yes? So this section here is between 3 and 2, this is between 2 and 0, and so this is the bit we're going to change the sign for, and then we're going to add on the integral between 3 and 2. Yeah? Right. It's the integral, so we're integrating this expression here. It's the calc paper. It's worth only 3 marks. Okay? So because it's in the calc paper and it's worth 3 marks, as long as you've shown that you've been doing this stuff, this is what's going to get you the marks. the actual integration of substitution that it is not necessarily going to get you any extra marks. And this is part of your exam technique that you have to appreciate, that when something is on paper 2, when you have your calculator available to you, do not do more work than you need to. Chuck it in the calculator. The hard stuff here was making sure you're splitting it. So, let's do it. Make sure you press Math 9. Okay, so Math 9. Do the between 3 and 2. Obviously, your calc, you're going to be putting the letter X rather than the T, because that's the only variable it has. Then you're going to do it between 2 and 0. When you do it between 2 and 0, you'll see that it's a negative number, and you're going to ignore that and just add the two together. All right, so then we get no. All right, so this one is a nice one. It's a show that question. But you have to be careful with show that question. Try not to look too closely at this just yet. It says show that the acceleration is given by that. So we know to find the acceleration. What do we do with this expression? Differentiate. Yeah. Okay, so we're going to differentiate it. So the acceleration is going to be the dv dt. So we're going to differentiate it. So dv dt is going to be going back up to here. What have we got here? We've got a bracket with a power outside it. So we're using our chain rule here. So we're pretending that this is just a letter. Just now stop talking.
I wasn't even talking.
But you're not paying attention. This is where the action's happening.
I know, I was just turning around this time.
So, if something is raised to the power of 3, the power comes in front. We're pretending this is just a letter. So it's going to be 3 bracket t squared minus 4 to the power 2. Yes? So remember, we're pretending that the bracket is just a letter. So we're saying 3 comes in front, take 1 off the power. But then what do we have to do to that expression? We have to multiply by the
differentiation of inside.
the derivative of the inside. Yeah. So what's the derivative of the inside bit? 2t. And lo and behold, how does that simplify? Well, we've got 3 multiplied by 2t gives us 6t. And there we've done what they've asked us to do. Right, okay, so ladies, so having established that we can plot both those graphs, one of them would have looked like this.
Oh my gosh, it's 10.
Okay, the other one did something like this, I believe. What was in front of them? Oh, same kind of eating work. Yeah, doesn't look like it at all. And so what they've said is, where are the velocity and acceleration both negative or both positive? Well, are they both negative anywhere and both positive here?
No.
Are they both negative or both positive?
Yes.
Yes. Can you see that here they are both positive? Yes. So how would I describe that? Positive coordinates from 2 to 3. So it's 2 is less than t is less
I was
than
thinking
3.
it, those guys. I was thinking it.
Okay, now you probably would have been able to say t is greater than 2. Let's say what it's 2.
You lied? It's not 2. I thought the marathon was going to be paying.
Wait, that's not 2. Remember, this was 2 because this is where it was 0. Yeah? So, we could say this as well because we don't really know what's happening. Or you can say this one because we know we were only talking about the function up to the value of 3 anyway.
So which one?
Either of these two are fine. Alright, are you all happy with that?
Yeah. Yes.
So because I can't stress it enough, because it's a calculator exam, use the calculator. Don't make things hard for yourself. Use it as much as you possibly can. Okay? Any questions about that?
No.